Hi Brandon, it's Monday morning and we're hoping you're going to get in here soon, but we're going to make this in case you need to watch it this evening. We're sorry that you're not with us. We were talking about the lunar eclipse last night. Hope you enjoyed it as we did. We're starting the second mod. Let's show him the paper and just get a picture of that. You can title it More One-Dimensional Motion. More one-dimensional motion.
Great camera work. Okay, got it.
Got it? All right. And you'll have your own to write on. And we're starting with developing an equation. So I need someone to go to the board. Does anyone want to go to the board? Brian, come on up. And Brian's going to, with my instruction, he's going to develop the first equation. Do you see where it says equation number 1? That's where you're going to write down what I ask him to write down, and I'll take his seat and he can take my position. Brian, start all the way to the left and write the equation for acceleration. A equals change in v over change in t. There we go. Everyone write that as he does. Change in v over change in t. V, is that a V?
That's V?
Yeah, like velocity. That's good. Change in V as in violin, over change in time. All right, now under that, rewrite that and say A equals, instead of change in V, what can we say sometimes instead of change in V, Emily Davis? What can we do instead of change in V? Something minus something.
Velocity 2 minus velocity
Right,
1.
velocity 2 minus velocity 1. And on the bottom, write time 2 minus time 1. So that's just another way of writing that. So write it as he does. All right, step to the side and they can get that down. And now, normally, almost every one of our problems, time 1 is what? Emily Keene, what's time 1 most of the time in our problems? What do we usually start our problems at? Time equals... Yeah, that's almost across the board. It is possible, but we're gonna imagine that time 1 is always 0. So therefore, and we're going to rename V2 and V1 the way most physicists do. So under that, Brian, you're going to put A equals, and when you get to V2, you're not going to call it V2 this time. You're going to call it, so write A equals. When you get to V2, you're going to put just V. Just V. So everyone knows when they see v by itself in the equation, they're talking about the final velocity. So just drop the little subscript 2 and just call it v. Now, I would like you to keep the v sub I. So all you're changing now is v minus v1. And I'm sorry, you do change it. It's v sub I. What do you think the little I is going to stand for, Zach? Velocity, pardon? Not instant, that was a good guess. Initial. So V1 is, we're going to upgrade V1 to VI, and that's what we normally see in most textbooks. So Brian, I need your V2 to be V, and your V1 to be VI.
So V minus VI.
Yeah, V minus VI. And on the bottom, we're going to scrap the idea of T2 minus T1, because T1 is almost always 0, we're just going to call it T. Alright, can you handle those changes? We got them down? So you got V minus VI over T. Alright, so no changes in theory, just changes in symbols, okay? Now let's mess with that for a minute. Brian, I want you to pull your algebra out and solve that equation for V. So V means V final, so you're going to do some algebra. See if you can do the algebra at your table as he does it on the board. He's going to get V by itself. And would you please rewrite it so v is on the left and your equation is on the right? I also want v sub I in the first position and then your AT. Perfect, thank you. All right, that's our first equation. Make sure you have its derivation down and circle or square or star the final result, the last one he has up here. Do we have any idea how long that took? Because I forgot to time it. Why don't we just...
Probably not that long.
Pardon?
Probably nowhere near 15, I don't think.
Okay, if you say so.
Maybe like
Probably been like 5
All right,
or maybe.
V.
just do 5 more minutes then.
Okay.
All right, I don't care if it's short, it's just long I don't have. This is your first equation. There's going to be 3 in this chapter, and this is our first one. And they're just equations for one-dimensional motion. And I want you to make a note about this one. Here are all the variables that we look at, v, vi, a, and t. You see those variables in that equation, but there's another variable that's missing, and that's x for distance. So note this, right around here, I want you to write a note. No information about x, which is distance, or I'll call it displacement. That's how we usually think of it now. So there's no information about distance. So if you're doing a problem that has a question about distance or information about distance, this is not a wise equation to use. However, there's plenty of scenarios where it is. Brian, were you going to ask something?
This is equation 1.
Yes, equation number 1.
Yeah.
So this is it in all of its glory. The other thing I want to change about this is, you'll see it like this a lot, but as another way of writing this. So I want you to be used to all of them. And in fact, the little memory I made, the memory jingle I made has this not as an I, but as an O. So this means velocity at time 0. Which is the same as velocity initial. So it's just another way of saying it. So let's do one more line and put this as our final. V equals V sub O plus AT. I have a little jingle to help us remember that, and then we'll use this equation to solve the first example problem, which you'll see will be very helpful. So the little jingle is, I'm very, oh very, V starts with, very starts with V. So I'm very, oh very attached. Do you see where I get that?
Oh, I see what you did there.
All right, everyone say it with me. And here's what we do. We go, I'm very, oh very attached. So I'm very, oh very attached. Again, I'm very, oh very attached. Again, I'm very, oh very attached. Once more. I'm very, oh very attached. So you see where that kind of helps your memory to that equation.
The initial velocity is usually a lot of times it's at 0, so you can put velocity at time 0.
Yeah, velocity times 0. Right. Okay. So let's do one. Let's shut that down, and we're gonna do. Let me show.